How's it going, ladies and gentlemen? Mr. Donahue here with some 11.6 phase diagram problems. All right, let's start with 24. On a phase diagram, the critical temperature is blank. So remember, phase diagrams kind of look like this weird thing going on, right? And then, depending on, that changes. What it looks like changes based on what you're looking at. But the critical temperature is basically right here. It doesn't matter what pressure you put it under, you're not going to be able to liquefy. That's the definition of the critical temperature. So it's the temperature above which a gas cannot be liquefied. So if I recall correctly, we got temperature and we got pressure here. So it doesn't matter. You can't liquefy it. It's probably the other way around, isn't it? Yeah. Donahue, no, I got that right. All right. Anyway, moving on. 25. The phase diagram for a substance has a solid liquid boundary line that has a negative slope, leans to the left, the substance blanks. So if you take a look, what they're talking about, let's draw it out. Instead of just trying to picture this in our head, let's free up some space in our brain for thinking by drawing it out. And it's saying the solid liquid phase boundary. So that is this line right here, where you start off solid, liquid, gas, has a negative slope, leans left, the substance blank. All right, so again, we got pressure and we got temperature. And over here, we got our critical temperature. Here we got our triple point. And then they're talking about, well, what's true for this? All right, it says it can go from a solid to liquid within a small temperature range via the application of pressure. Let's see if that's true. All right, let's say it started as a solid and I increased the pressure. Well, that would move it up and it would become a liquid. Yeah, that's kind of like ice. Ice will liquefy under pressure. So A looks true, but let's check the other ones. Sublime rather than melts under ordinary conditions. That doesn't affect it at all. The slope of that line has nothing to do with that. Cannot go from a solid to liquid by application of pressure at any temperature. That's not true. It just showed that it could, Cannot be liquefied above its triple point. That's not true, right? Triple point, here it is. Here's a whole region over here where it can liquefy. Melts rather than sublimes under, that has nothing to do with it. So it's definitely A. 26. On phase diagram above, segment blank corresponds to the conditions of temperature and pressure under which the solid and the gas phase are in equilibrium. So you got to remember which parts of these are what phases. So solid, liquid, gas. So this section right here is in equilibrium between the solid and the gas. So A and C, line segment AC. Same chart, different question. On the phase diagram shown above, the coordinates of point blank correspond to the critical temperature and pressure. All right, so critical temperature and pressure is going to be the B over here, right? So again, if you go past that temperature, if you're over here, it doesn't matter what you do to the pressure, you cannot liquefy it. It doesn't matter. Whereas over here, if you had a gas under, right here, if you increase the pressure, then it would become a liquid, right? But once you're past this temperature, there's no liquefying it. 28, different question, same picture. On phase diagram above, the coordinates of point blank correspond to the triple point. This is the triple point. Kind of makes sense. You got 3 points coming together to give you a triple point. So what's cool about the triple point is that's where an equilibrium between all 3 phases can exist. You can have an equilibrium between solid, liquid, and gas. All right, so normally melting, you think, all right, well, that's solid to liquid. That can be an equilibrium, vaporization, liquid gas equilibrium. But right here, you got equilibrium between all 3 of them, which is pretty neat. 29, phase diagram of substance shown above. The area labeled blank indicates gas phase for the substance. So again, you got to remember colder parts. This is an easy way to remember. Colder is the solid. So solid's over there, and then way out over this way would be the gas, and then what's in between, the liquid. So phase, the area labeled blank indicates gas phase. Looks like they're talking about Y. All right. Phase diagram of substance shown above. The area labeled blank indicates solid. W. That's it. Right. And that's pretty much phase diagrams. So hope you didn't find that too difficult. If you did, see you in class.